Namaste बच्चों, welcome back in third lecture of chapter Matter in our surrounding. In last video, we have discussed about the different states of matter, and today I will discuss about the changing of states of matter. Okay. Or in other words, we can say what is the effect of temperature or pressure that will be discussed today in this class. Okay. Yeah. Now we'll see the effect of temperature by one activity. In this activity, we have taken one iron stand, one beaker, one thermometer, one glass stirrer, beaker, ice blocks, burner. Okay, we will make this arrangement and start heating the ice blocks in beaker. What we will find? First of all, we can note down the temperature in thermometer before heating starts. Then, when heating started, continuously will noting down the temperature in thermometer. We'll see the temperature at which ice starts melting. Now, heating goes on continuous way. We'll see during melting of ice, the temperature of thermometer it will remain constant, and when the melting completes, then the temperature starts rising. Okay, when again the temperature when the whole ice blocks melted, we start stirring the mixture with the help of glass stirrer, and we'll see again when boiling is going on, again the temperature remains constant. What we are concluded here that during melting of ice blocks means when melting starts and till the completion of melting, the temperature in thermometer remains constant. Again, when boiling starts till boiling of whole liquid means until the evaporation completes, the temperature remains constant. So, in this activity, we see the effect of temperature that due to the temperature, the substance change its state from solid to liquid or liquid to gas. Now, question arises: why the state changes from solid to liquid or liquid to gas, and during changing of state means during melting of ice into water, the temperature remains constant, and during boiling of water, the temperature remains constant. There are two questions. Okay, we'll see one by one. Before that, I want to discuss melting point, the definition of melting point. See what is written here. The melting point of a solid is an indication of the strength of the force of attraction between the particles. See what happens when we heat the ice blocks, the force of attraction, whatever is present between the molecules of ice, are being overpowered by the energy supplied during heating, and then the ice blocks change into liquid. Means the energy of particles of ice increased and they start moving with the high speed, and they are able to free themselves from each other, and that's why their state change from solid to liquid. It is due to the increase in energy of ice molecule, and then they convert into water molecule. Okay, so what I've written here in the melting point, it is an indication of the strength. Means if any substance has high melting point, it means its molecules are attached with a stronger force of attraction. Okay, if any substance has high melting point, it means it is attached with a higher force of attraction. For example, iron melting point is more than 1500 degrees centigrade. It means the molecules of iron, the particles of iron are held with a strong force of attraction. Similarly, the melting point of diamond is more than 3000 degrees centigrade. It also shows that these molecules are attached with a more higher force of attraction. Okay, so the melting point shows the strength of force of attraction of particle, and it is overpowered by the supplying of energy during heating. Means when we heat any substance, we supply extra energy to the particles, and that's why they become free and change their state from solid to liquid or liquid to gas. The melting point of ice is equal to 273.16 Kelvin. See, Kelvin is the SI unit of temperature. Uh, it is also, if we write in centigrade, it is equal to 0 degrees centigrade. Okay. Actually, we used to write 0 degree equal to 273 Kelvin just for our convenience. Okay. And I will show you later. To convert Celsius scale into Kelvin, we add 273 into Celsius scale reading, and to convert Kelvin to Celsius, we subtract 273 from the Kelvin scale reading. These are the units of measuring temperature. Okay. So the now second question: during the above experiment, the temperature does not rise while melting of ice. Why? Yes. Why the temperature doesn't rise? In this activity, we have discussed that while melting starts, the temperature remains constant till the completion of whole melting of whole ice blocks or ice cubes. The reason behind that is the energy what is supplied to this ice blocks is used in converting the solid ice into liquid water. Means it is used up in breaking off force of attraction among the molecules of ice. That's why the temperature doesn't rise, but the energy of water, that is changes from ice, increases. Okay, here the water which is obtained after melting of ice has more energy than that of ice at same temperature, because the energy what we have supplied to the ice, that is being used by ice to convert into water, means that water has extra energy that is supplied to change ice into water. That's why the temperature remains constant. Same case happens in the case of changing liquid into gas. Suppose when liquid starts boiling, during boiling means during evaporation, compression, the temperature remains constant. It means what? It means that the energy what we are supplying, that is being used by the liquid to change the liquid into gaseous form, means it is used to overpower the intermolecular force of attraction of the molecules of liquid, and that's why the temperature remains constant. But at the same time, the energy of that vapor or gaseous form of substance is higher than that of the liquid substance. Okay. See, now that on that energy that is being used or that is taken by the liquid water or vapor form of substance is also called latent heat. Latent heat or it is also called the hidden heat. Now we'll come on that point, that is called latent heat of fusion and latent heat of vaporization. We'll see one by one. Okay. First of all, about the latent heat of fusion. The amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. See here there are 2 points, that is atmospheric pressure and at its melting point. These two are very important. Melting point and atmospheric pressure. See how. In the experiment, what we have seen, when we heat the ice blocks, it converts into water, the temperature remains constant. It means the energy that is supplied from outside, that is being used from ice, changing from ice to water, and that is called latent heat of fusion. Here, same thing is written, but one word is added here, atmospheric pressure. It means the pressure, that is a standard pressure, means what we feel at sea level. See what is atmospheric pressure, that you will detail study in your physics portion. But I want to say here, pressure varies at different height. On Earth, the sea level is taken as a standard place for measuring standard pressure. If you are talking about the atmospheric pressure, that is called standard pressure, that is at sea level pressure. Okay. In latent heat, we use this word atmospheric pressure, and at its melting point means you have to see that latent heat will be that heat when a substance changes from solid to liquid at its melting point and liquid to gas at its boiling point. Means in these two cases the temperature remains constant, means the boiling point should be maintained or the melting point should be maintained. Then only we will discuss about the latent heat of fusion. The amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as its latent heat of fusion. Means that heat is just simply hidden by the different form. Suppose here ice is there. Ice when heated, it changes into water. So this ice is supplied with energy, and that energy is taken by the water. Means water has the extra energy. So this extra energy is called latent heat. Although both have same temperature, means ice will melt at 0 degree centigrade and the water change will also have the same temperature. Also have the same, means it is at 0 degree centigrade, it will be also at same temperature. Both have temperature is same, but the energy is more in this water, means this, that's why if we touch the ice and this water, we feel more cold ice, but water will not feel more cold because this has more energy in the form of latent heat or in the form of hidden heat. Okay. Now the boiling point. The temperature at which a liquid starts boiling at atmospheric pressure is known its boiling point. Means suppose we are heating a liquid and it starts boiling. The temperature at which it starts boiling is called is boiling point. Now question, how boiling starts? Again, as we are supplying energy, the energy is used by that liquid to overpower the intermolecular force of attraction, and the molecules will get extra energy, and that's why they convert from liquid to gaseous form, and it is called the boiling temperature of that liquid. Okay. The boiling, suppose in the case of water, the boiling point of water is 100 degrees centigrade. It is also equal to 373 Kelvin. What I said you earlier, that these two are the units of measuring temperature, centigrade and Kelvin, where Kelvin is the SI unit of temperature. To convert centigrade to Kelvin, we add 273, and to convert Kelvin to centigrade, we subtract 273 from the Kelvin reading. Okay. Now about the latent heat of vaporization. Okay. The amount of heat energy that is required to change unit mass of liquid into vapor state at its boiling point is called latent heat of vaporization. Same way as in the case of latent heat of fusion, we'll describe latent heat of vaporization. Means if we heat a unit mass of liquid at its boiling point, it converts into vapor, and during that conversion the temperature remains constant. It is called latent heat of vaporization. Okay, means at again the liquid and the vapor both are at same temperature, but vapor has more energy than that of a liquid. See, suppose I write here boiling water. Boiling water converts into vapor. Water boils at this temperature 100. Vapor will also form at 100. Okay, both have same temperature, but the energy is more in vapor than that of boiling water. A question is there in your exercise that when we touch or when we feel the heat of vapor is more than that of boiling water, because vapor has latent heat of vaporization, means vapor has hidden energy, because boiling water is supplied with energy, then only it converts into vapor. Although temperature is same, but it has more energy than that of water. That's why vapor produce, or steam, it is also called steam. Steam produce more heat than that of boiling water. Okay. Now see one diagram here. Solid state when heated convert into liquid state. Liquid state when heated convert into gaseous state. Again, when gaseous state of any substance cool, it convert into liquid state, and liquid states cool into solid state. So these all changing of state are due to the change of energy of the molecules of those form of substances. Mean at solid state the particles of this state have less energy than that of liquid. Means when energy increases, they change into liquid state. Again, in liquid state the energy of particles is less than that of gaseous state. Means when this energy is increased, they change into gaseous state. Okay. Similarly, the gaseous state matter have the highest energy. When the energy is decreased, means by cooling, by lowering the temperature, the energy is decreased, and they convert from gaseous state to liquid, and again liquid to solid state. Okay. That is all about the effect of temperature of on different states of matter. In next class, we will discuss about the effect of pressure on different states of matter. Thank you.